book, you need to define what a chord is, use a picture, and then answer questions 5 and 6 on page 600 using your note page. Okay, so a chord is when you have a circle and, well, you guys tell me, what's the definition there? Oh man, I got a couple. All right, Nick?
Segments with endpoints on a circle.
Good, it's a segment with endpoints on a circle. Alright, so if I take a segment, I put its endpoints on the circle, that's a chord. Now it could be multiple different looking chords. Okay, question 5 says, is a diameter a chord?
No, yes.
Yeah, diameter of a circle has its endpoints on the circle. Okay, how about is a radius a chord? No. So you've got your diameter, its endpoints are on the circle, versus a radius, okay, it only has one endpoint on the circle. Alright? Questions there? Okay, I want you now to use a picture to summarize theorems 12, 5, 6, and 7 on page 601, and picture to summarize theorems 12, 8, and 9 on page 602. Now remember, also on your note card, you should probably get some of these theorems and this information down that you don't know. Okay, that you're ready for your quiz on it, so that you prepare there. These theorems, theorem 12.5, okay, and all of these start with the same way, in the same circle or in congruent circles. Theorem 12.5 talks about congruent central angles have congruent arcs. Okay, so if the central angle is the same, so 60 degrees, 60 degrees, then the arcs are going to be congruent as well. Okay, so your central angle tells you the measure of that arc out there. So this 60 degrees means this arc is also measures 60 degrees. Okay, so arc BC is congruent to arc YZ. Okay, and congruent arcs have congruent central angles. All right, theorem 12.6. Theorem 12.6. Congruent chords have congruent arcs, and congruent arcs have congruent chords. So if my chord length is 4, then the arc that's created by that chord intersecting the circle, arc CD, would be the same as an arc in another circle or in the same circle that has the same, that's formed by a chord of the same length. So this chord is 4 and this chord is 4, therefore CD is congruent to AB. Their arc lengths are congruent. Okay? Any questions on those two theorems? Theorem 12.7. EG is congruent to FG, or arc EG is congruent to arc FG. So we've got EG to FG. The diameter bisects chords. Bisects chords and arcs, and the diameter is perpendicular to a chord. Okay, so in this case, since that's congruent to that, you have a right angle and this chord is bisected. Or vice versa, you could say since the chord bisects EF at a right angle, it's also bisecting this arc EF, and you have congruent parts here and congruent arcs here. Theorem 12.8. The perpendicular bisector of a chord contains the center of a circle. So it's a little tougher to see, but if this line right here is my chord, and this line right here is a chord, the line that's perpendicular to those, that cuts through it, is a perpendicular bisector to each of those chords, will go through the center of the circle. So if you can't find the center of a circle, however you have two chords, you could create the perpendicular bisector to those chords and see where they intersect. Okay? So for instance, if I drew a different picture here, best I can in terms, that's a horrible circle. We're going to try a different circle. Nice if I had my perfect circle maker here, but we'll go with that one. That one's a little better. It's not quite as good, but still. Okay, if I have a chord and just freehand another chord here, all right, and I were to create the perpendicular bisector of those chords, so cutting them in half, so that's about halfway there, and going through at a right angle, okay, which is what we're doing right there. Okay, we're cutting it at a right angle. And same thing here, going in half, cutting at a right angle. Okay, if those are perpendicular bisectors, then the point where they intersect is going to be the center of your circle. Okay, now we can actually do that construction. We're not going to be asked to do that. You're going to be asked to apply the theorem. That's why I'm not worrying about the construction piece of it. Okay? Okay. Whatever centers you have to find, you can just use a freehand on it and a ruler. Okay, 12.9, chords equidistant from the center of a circle, or from the center, are congruent, and chords that are congruent are equidistant from the center. So if I have two circles, and the chord is the same distance from the center of the circle, in this case 3 units, then these chords would have to be congruent. Okay? Now how many of you knew all that about chords? How many of you knew what a chord was? Not like the one you plug in. Okay. So now you know. Okay, we have some things that we're going to apply. So you want to make sure you add some of this stuff to your notes at a later time. Okay? Any questions there?
Can you go back to 12.5? I want to see the picture.
12.5 or?
Yeah, just that one right there.
All right. Okay. On the other side of your note page that you picked up on the way in, there's an activity. Okay? I want you to start with problem 1, and I want to work through it with you. Okay? The directions say find x using the information given and the measure of arc AB. Okay, so I also want you to find arc AB. I added this piece in there. I don't think this is on your assignment. Is that part on your assignment? No, I want you to add that piece of your instructions. I want you to find the measure of that arc as well. Okay? So, looking at this, I know AB is 20. So we can do some labeling here. I know that this entire length is 20. I know some people get pretty particular how they label. I have a different color, so I'm just going to say that whole thing's 20. I know my radius is 15. So anytime you can make right triangles, that's really helpful. So in this one, I can make a right triangle right there. I could also make one on this side. Okay, but my radius is 15. My job is to find what CM is. That's what X. Okay, and our goal is to figure out what X is. All right? So if it's helpful to you, pull that triangle out and redraw it. That sometimes helps out students. If I redraw that there and call this C and this M and this B, and then I got my 15 here, this is X. What's this length? 10. Now how do we know it's 10? Someone raise their hand and tell me. How do we know it's 10? Hannah, what do we got?
Oh, because the line C or whatever the other point you want to call it bisects the angle, which cuts the chord in half.
It cuts the chord in half, it bisects it. How do we know it bisects it? How do we know it just doesn't intersect it? Emily?
Because it uses the center.
How do we know it uses the center? Oh, you mean the center of the circle?
Yeah.
Okay. Yeah, so it has to go through the center of the circle.
Theorem 12.7.
Eli? And we have the right angle there. Okay, that's another way. So this is 10, very true. So I now have 10, I have x, and I have 15. Tell your neighbor how you're going to solve for x. We've got the Pythagorean Theorem. We've got x squared plus 10 squared equals 15 squared. X squared plus 100 equals 225. We go ahead and continue through. We get x equals root 125. Simplify your radical, 5 root 5. Now, how many got that? Okay, now here's the question. How are you going to find the measure of arc AB? Go and talk it over. You get about 10 seconds to discuss it. Give your neighbor your first thought.
Can't we just like learn about it? And then this would be,
Okay, time's up. How are we going to do it? Give me a thought. Hannah?
since triangle CMD is a special triangle, that'd mean the farthest angle would be 30.
How do we know it? Hold on, pause. How do we know it's special?
Because it's a right triangle.
It is a right triangle. It's not a special one, unfortunately.
Oh, it's not.
These would have to be done. So this would have to be 20.
Oh, okay.
Okay. So it's not special. I mean, it's nice. I mean, you're a nice triangle, but not special. Lee. What else have we done this year with right triangles? Just finished a whole chapter on it. JJ? Good. Our trig function, sine, cosine, and tangent. So if I want to find arc AB, I know that half of arc AB is this angle right here.
Yep.
So if I can find this angle, maybe I call it y, because, All right? Go ahead and use your measurements, one of your trig functions, and find arc AB. In this case, since you know the exact values of all sides, you can use any of the trig functions you want. Just make sure you're using the correct sides. Okay? Go for it. Which trig function are you using?
I use cosine.
How many use sine? How many use cosine? How many use tangent? Some of you didn't raise your hand, meaning you're not doing it. Either that or you're not wearing deodorant maybe or something. I don't know. Come on, man. Raise your hand if you're sure. Sine?
Oh.
Cosine? Tangent? Okay. We're going to go with sine. So we have sine here. Most of you use sine. So if I say the sine of y, the angle we're trying to find, is equal to opposite over hypotenuse, right? That's our trig function. Now that you've done this, I expect you know how to do that. Okay, so if I'm trying to find an angle, remember I'm actually using an inverse function. The inverse sine of 10/15. The inverse sine of 10/15 is 41.8 degrees. Okay, so it's approximate. All right, that gives me this angle right here. I want to know, which by the way is this arc measure here. That's 41.8 degrees. If I want to find AB, what's this? Well, this is also 41.8. So it's a total of?
83.6.
Good. Measure of arc AB equals 83.6 degrees. Now remember, a measure of an arc is different than a length of an arc. Measure is your angle measure. The length is if I took a string and laid it across it. How long would that string be? It's a portion of your circumference.
Then don't you just do like 360 over something for that? Like,
Yeah, you'd have to figure out, yeah. Okay? Questions? Okay, I want you to try number 2 and 3. Okay, work together. I'll give you guys about, I don't know, a little while.
oh yeah, 2.
That's what I have.
4 root 4.
Now you'll notice in my picture, I've sketched in I put in the information they give us. AB is 24, so half of AB is AP, which is 12, and that's 12, and that's 12. I know they don't look the same, but based on what they give us, each of those lengths are 12, which makes that a special right triangle, makes it a 45, 45, 90, right? So x root 2, that means this is 12 root 2. Or you could have used the Pythagorean Theorem and got 12 root 2. How many got 12 root 2? Okay? And from there, you then can use, in this case I used inverse tangent. I already know this is 45 though. Right? If you recognize it right away as special, if that's 45, that means this over here is 45, meaning this whole thing is 90. If you used inverse tangent, you would have inverse tangent of...
Wait, what'd you get? 2 root 6.
You can recognize those special triangles, it helps you out. Special right triangles. So 45, 45, 90. Giving us our 12 root 2. Get 2 of those angles gives us 90. Hey, you should be working on number 3. On number 3, going through, you got your triangle. This is, if AB is x, this is x root 2, or a half of x. Okay? And CP is 5. Okay, so if you go through and you solve it, you have 5 squared plus y squared equals 9 squared. Alright? And Everyone got that?
Yeah.
You get 2 root 14, and so you need 2 of those, though, right, to find AB. So that's what they're looking for is x. So 2 root 14s is just 4 root 14. Okay? Don't get confused by the math e's right here, right? I'm just saying I need 2. If I'm calling this length y, which I did right here, I need 2 of those to make that. Okay? Everyone get 112.5? It's supposed to be 112.5. Yeah? How many used a different function than I used? Anyone use sine? Tangent? Cosine? Who used cosine? Well done.
I don't like using it.
Okay. Any questions on it? Okay. Very good. I want you to take a look at the next problem down there. Take a look at some of those word problems. Okay. Number 4 says find the length of a chord that is 1 centimeter from the center of the circle, radius of 6.
7.
Number 5, find the length of a chord that's 8 centimeters from the center with a radius of 8.1. Number 6, find the center, or for a circle with radius 10, find the distance from the center to a chord. And number 7, for a circle with radius 8, find the distance from the center of a chord to the length, to a chord with a length of 15. I want to skip this one right now. Number 6 and number 5. I want you to do numbers 4 and 7, please. Okay? Work with your groupies. Draw a picture, please.
83 dropping an altitude.
All right. Hey, let me show you my picture. There's number 4. Now, I don't want you to see number 7. 1.
You want it.
All right. For those of you that are struggling a bit, this picture right here, okay, it has a length of 6, right? Yeah?
Yep.
Radius of 6. Okay? It's 1 centimeter from the center, and we have this length of x. So if we just use the Pythagorean Theorem, 1 squared plus x squared equals 6 squared. So in this case, there's our work. You'll notice once we get what x is, we have to double that because we need 2 of those. Okay? So from here to here. So if x is 2 or 1 root 35, you're going to need 2 of them, so it would be 2 root 35s. Did you get that?
Yeah.
Do you guys get it?
Yeah.
Raise your hand if you got it. Okay. Everyone's on the last one?
Yeah.
Okay. Give it a go. Finish that up. I almost gave away the picture. I want that. Sounds like most of you are done with it. There's number 7. 2.78?
What? Yeah.
Yeah. 2.78. X squared is 7.75, so you got to take the square root.
Yeah.
Or 30 root 31 over 2.
Okay. Make sure you recognize that this length is 7.5 because the total is 15. Okay, radius is 8, so x squared plus 7.5 squared is equal to 8 squared. Okay. How many got it right?
Yeah.
Okay, assignments to mixed side. Make sure you're asking for help. Like I said, in about 5 minutes we'll correct yesterday's.